If it is a coordinate transformation, what happens if you have, let's say, dx vector dx alpha is going to dx prime of alpha. Dx alpha is going to dx prime of alpha. This dx vector can be written as, so we can say that your dx prime of alpha can be written as, because this dx prime of alpha will be a function of all these x alpha. So you can say that this can be written as dx prime of alpha by dx beta into dx beta. Dx prime of alpha into dx beta into dx beta. Of course, let me write here for clarity, this is sum over beta. Correct? Dx prime of alpha. So, now what do we understand from this? From this we understand, look at this one, dx prime of beta is sum over alpha, dx alpha, L inverse of alpha beta. So the transformation matrix, okay, so the transformation matrix, this L inverse of alpha beta, this is the transformation matrix, is nothing but dou x prime of alpha by dou x beta. Dou x prime of alpha into dou x beta. Now, the general definition which the outcome starts with is this. Any vector which has the transformation properties that are like displacement vector are called contravariant vectors. Okay, so it is now understood why this is called contravariant vectors, because we are choosing a coordinate basis, and choosing a basis in which coordinate basis is the basis in which the coordinates increase, and hence the displacement upon the change of basis will have a transformation like this, which can be visualized in this fashion. So the advantage of this transformation is that this is quite general, in the sense you take any vector. Suppose you have a vector A with components A alpha, and then you make a change of basis, this will become A prime of alpha. So you can say that A prime of beta will be equal to, I have the same transformation. I don't have, suppose if I call this as so let us call this as some lambda alpha beta. Okay, so I am going to have sum over beta lambda alpha beta times AB. What is lambda alpha beta? It's the same quantity. Whenever I am writing down summation, please understand that these things are not tensors. They are simply transformation matrices. And suppose if you have some tensor of this type, T of alpha beta will go over to T prime of alpha beta. Then you can write down P prime of alpha beta is equal to sum over gamma delta lambda of alpha gamma lambda of beta delta into A of gamma delta, so P of gamma. So this matrix is fixed once and for all. All those components, all those tensors whose components will be transformed on change of basis, like displacement vector, are called contravariant vectors. This is the definition that is given in mathematical physics books like Afghan. But we have actually seen more fundamental definition of this. A contravariant vector is actually a vector. This definition is used because there is no one form that is given in those books. There is no distinction made between one form and the vector. If you make a distinction between one form and the vector, then you don't have to define it this way. Based on the transformation property comes like this, is a consequence that it is a vector. Transformation property is a consequence that it is a vector. So if you define vector as a contravariant vector, then you don't have to define it this way. Displacement is a vector, so it will be a contravariant vector. So any vector will be transformed according to any other vector. Okay, so now let me look at slightly different quantity.